I'm Frank. I'm going to be doing some talking about Filesystem today. So as mentioned before, I'm from the Netherlands. So apart from the Netherlands being famous for the red light district, it's almost also famous for tulips, windmills, and funny people walking around with cheese. Apart from that funny stuff, we also have brilliant people in our history, like this gentleman over here, Mr. Van Gogh. He cut off his ears. Everybody was like, oh my God! But then we were okay with it. Just if you're wondering, yes, I am Dutch. No, I don't have any weed on me. So this is what the country looks like on the map. Fun fact for you, we're here in New Zealand. This part of Holland is actually called Zealand. So this part of Holland is why you are New Zealand. We've got the old one, like the original. Just to clarify some more things, I don't wear these, and they're not very comfortable. Also, I'm not high, I'm just a bit jet-lagged. So I'm going to be talking about file systems today. Warning up front, file systems are file systems. They're not fancy. They're a bit boring. I'll try to make it as fun as possible, but I can only go so far with making file systems fun. So beware. Also, I might complain and get a bit depressing during the talk. So what is a file system abstraction? Well, I'm going to be talking about that because the title says so. But what is a file system abstraction? If you would say it in one sentence, it's the encapsulation of file systems, so the storage engine, the actual file system, becomes an implementation detail. If that confuses you in any way or anyhow, don't worry, that's what this talk is going to be about, so you'll be a pro at the end of the talk. I've broken down this entire topic into 4 items, so we're going to run through them one by one, each building on top of the other. So, first of all, we're going to see what file systems actually are, what's the concept of a file system. Then we're going to see how we use them. Then we're going to move away from local file systems to remote file systems. And then we're going to be using a file system abstraction, of course. So, what is a file system? Basically, it's a two-legged thing. On one end, it's structure, and on the other end, it's logic. So it creates these things for us. So what's in a file system? These are like the entities, they're like the things that we're working with. And we can basically break them down into 3 separate things. We've got, obviously, files, but there are also directories and metadata. If we then look further into metadata and look what those things are, we have a whole wide range of things that we can distill from the files that we have in our storage system. Things like the location or the path, that's something we'll use to address something. Timestamps, when was it last modified, when was it last accessed? Things like that are important to us. We can use that. For instance, timestamps, if we create some kind of caching mechanism that looks at a file and sees if it needs to reparse it, we can use that to say, well, we're either going to do this because the cache has expired or not do it because it's up to date. And there are more things like permissions and ownership. But there's more. File metadata contains also things like MIME type and file size, and also the contents of the file. While it might be weird to look at contents as like a file metadata kind of thing, if we look at a file as just a blob of random stuff, everything is a property. So on that level, everything is basically the same for us from a user point of view. But we can also derive information from this. So if we use functions like pathinfo, we can get the file name, the base name, the extension, dir name, and MIME type used in different functions. But these are things that we can derive from the file. So now we know what's in there, but the other part is the structure. And if we look at the structure, this is basically everything that allows us to organize our stuff. And in general, there are two types of file system structures, which I've kind of laid out here. On the left, we've got the nested file system, and on the other, we've got the linear file system. And as you can see, in the nested one, we've got a directory, and inside that directory, we have our files. While on the other hand, we basically have the full path, and everything is a separate entity. So these are distinctly different. If we look at nested file systems, these are the things that are most common. If you open up your terminal, you're in some kind of directory, and then you cd into something else, and it gives a sense of scoping for us. We don't want to look at the file system as a whole, so this keeps us like in this narrowed space where we can look around. It's quite easy to see what's going around there. So they have directories. We can go into directories, and that can contain more directories and more files. So this helps us to organize. On the other hand, we've got linear file systems, and these are more like key value stores, like Redis. You could basically say that's the same thing. They can only have files. They don't need directories. They can have directories, but because they don't necessarily need directories, they require a different approach. Who here has used a linear file system? Okay, keep your hands up. Who has used S3? Okay, those are the same people. Normally, I've got a couple more hands coming up after I ask who has used S3, and then the big wow is that is a linear file system. Doesn't work on you because, yeah, it's the same people. Anyway, just pretend. So what I'm effectively saying is directories don't really exist. They're basically a myth. So we now know what file systems are, so we can now go on and use them. Again, warning, this is where I get a little depressing about PHP and file systems. So, if we look at a conceptual level, what we can do with file system basically boils down to these couple of operations. We can write, read, update, delete, and also do more complex stuff like moving, copying, and listing files, and then doing some random form of inspection in order to get metadata. Those metadata would be the MIME type or the timestamps or whatever you want to retrieve from a file that's not actually the contents. So if we then look at how we do in PHP, how we handle that in PHP, it's a bit of a pain. I'll try to illustrate that. It's not that bad, but yeah. In vanilla PHP, for local files, it's relatively easy if we do like simple operations. We can quite easily, using a function, we can call file put contents, we specify the location, and we specify the contents, and we're there. We can get the contents using file get contents. We have the contents. Also, really clear, not much going on. We can delete a file, which is obviously called unlink. Okay? Then we can get the timestamp, which is mtime, which is very consistent with everything not being abbreviated except for this one. But then we need to, for example, get the MIME type. Well, we used to have this very nice function called MIME content type. So no get, just random other words to get the MIME type, which was okay, but then they deprecated it and they had a replacement. And this is where it gets kind of iffy already. So we have to instantiate an finfo class, which is actually like this class is all lowercase. This example says it's capitalized, but it's actually not. So it's one of the only cases in PHP where the class is lowercase at the front, so it's already kind of weird. In the constructor, we have to pass some kind of flag, which in this case is file info MIME type, and then we call the file method on that object that we just newly created and pass it the location in order to get that. So this is already where you can see it being kind of broken apart. We've got all these functions, so we're using functions all the time, but as soon as we're getting MIME type, we have to instantiate objects and do weird kind of flag magic in order to get our information. So yeah, if it all was just consistent, it would be so much better, but it isn't. For listing files, it's basically the same thing. We can do a glob, we can do a scan, a read dir, a scan dir, and then pass the location. We can do a read dir, but it needs a resource and a handle, which we can retrieve from open dir, which requires the location. So okay, it's getting increasingly more complicated. But we have some nice other things as well, which are directory iterators. So if you want to use that and you want to have that in plain PHP array to just have the information as is, for instance, if you want to serialize it or store it so you don't have to address the file system every time, you need to normalize it in some kind of loop. But in order for that to do, you need to convert the iterator to an array. So it's already kind of complicated. But we might want to do a recursive listing as well. Well, that's the last part, and the funky indentation is required there because else the stuff would just not fit on the slides. So you can see this becoming increasingly more difficult, and one of the problems is, which one do I choose, and why do I choose it? If you want to do recursive stuff, then the last option is pretty much what you have to do. But do you want to write this every time like this? I would prefer not to, and I'm pretty sure you wouldn't either. So, concluding, one does not simply list directory contents. Also, files and everything we've used in functions that we saw previously to read and write that stuff, that's all string-based. But string-based stuff only goes so far. For larger files, you will have to use streams. So streams are fairly simple. We open a stream from the source path, and we need to pass it a flag or a mode to say we're going to read from this, and we want a pointer at the start, which is very obvious from the R+, which is very natural to us, of course. Once we have this, this resource, we need a new resource where we can write to, which is the W+. And then, while we're not at the end of the file yet, we're going to push over chunks of data to the new resource and then close it at the end to get the result and close the resource that we read from as well. This is fairly complex, and pretty much the operation that we do is a copy. But there's a problem there again. The problem is the source and the destination must be locally. You cannot use this, for instance, if you want to do file system interaction with, say, an FTP server or AWS. It just won't work, unless you're using stream wrappers, which are overly complex as well. So, concluding, I do not like this. So, we now know what file systems are. We know how to use file systems. You know that I hate doing it that way. But I've got more stuff to hate on, which is moving to remote file systems. So, working with other file systems, I mean everything that's not locally. So, you either work with something like an S3 bucket or an FTP server or Dropbox, perhaps. And there are quite a few reasons why you'd want to do this. say you have an application and you're storing user files, and you've got a cat picture website, and all of a sudden you gain massive popularity, so your single server can't handle the traffic anymore. But you're using the local file system, so you want to scale out, so you want to have multiple instances running your website. Well, what happens when somebody comes to your website and load balancers say, hey, you're going to server A, and you're uploading something, so that server will have the file, and the next time somebody wants to actually view the file, but the load balancer says, well, you're going to server B because server A is busy. All of a sudden, the file is not there. So we need to remove that file system state away from those applications, and we want to centralize them or use some kind of service for it. So we want stateless apps. Another valid reason would be if you were not in the business of serving files, then probably you want to use a service which does that for you. Serving files is it's not overly complex on low scale, but on high scale, availability issues can arise, and you can offload the work that your server needs to do to move things to a CDN, for instance. So that's one use case, or you could allow your application to have multiple kind of services, and if they can pass files over, like one is reading a file that another service has written, you have some kind of communication going on there. For instance, well, you won't do that with PHP per se, but if you would have a video platform, you need to do some kind of transcoding, so they're actually working on the files and multiple servers have to access files, so you want to centralize that. But these things come with a couple of consequences. One, we can't use built-in PHP functions anymore. We'll have to start using APIs and SDKs that come along with it. So you'll have to start depending on third-party code. Let's look at some of those third-party things. The first example is an upload to S3. If we want to upload a file or write a file, we need to say put object. So all of a sudden it's not a file anymore, we're uploading an object. Well, okay, I'll just take that as a given. And we need to specify some options for it. And it looks fairly like an HTML, HTTP request or of some sort. So we pass it a body, a content type, which we need to specify. If you don't do this for S3, for example, it will always be octet stream, and when somebody downloads the file directly to the browser, it would have the wrong MIME type, so your browser won't know what to do with it, and it will force download. So this is something that you have to take into account every time. Also, in order to leverage some of the more advanced features of the S3 SDK, you need to specify what the content length is, because the actual SDK backing this can do concurrent uploads, but you don't want to have to think about those kind of optimizations every time you're uploading a file, but you have to. Then if we look at Dropbox, we say upload file from string, okay? We specify the location, we give it the contents again, but then there's this new concept called a write mode. And based on whether the file was pre-existed or not, we need to say either the write mode is add, but if it already existed, we need to say overwrite. So all these things that we need to take into account. And there are more vendors that do this. Once again, Rackspace, it has an upload object, so once again referred to as an object instead of a file. Fairly simple, we specify the location and we specify the contents. But then WebDAV, which is a HTTP-based protocol for using files over HTTP with some other kind of logic, we request, because we're writing, which doesn't fly in my book, but okay, we need to say put, which is a HTTP method, but I'm writing a file, I'm not doing HTTP. So, okay, we once again specify the location and the contents. So different kind of concepts that I need to be aware of. I actually need to be aware of the WebDAV protocol here in order for me to write a file there. So I don't very much like that. The last one that I'm going to be complaining about is FTP. Who has had the pleasure of working with FTP over, like FTP in PHP? I feel sorry for you because it's a pain. Everybody who's worked with this knows that you basically write this code and hope that you never have to touch it again. It's so horrible to do. Already in this super tiny example, I can illustrate something that's wrong with it. For instance, everything we did before, we uploaded a string, which is very simple, of course. But all the FTP functions, they don't support strings. You have to pass it a stream. So if we want just some string to be uploaded to a file on an FTP server, we have to create a stream using tmp file to create a temporary file and get the handle returned. We write our contents to that stream, and then we use the FTP fput function to write it to the connection destination stream, and then we have to specify what kind of upload mode there is. So you can either do FTP binary or FTP ASCII, and you have to know which one is correct. Well, most of the times, binary is just what you want, so it's pretty good to go with that, but yeah, you don't want to have to take that into account. And then, after you've done that, you need to close the stream, and actually the response of that fclose and the consecutive fput calls will all give return statuses, so you actually have to monitor that in order to see if somewhere along the upload process things are broken. So a lot to take into account, and this is literally just 5 lines of code. So there are some obvious downsides here. We've got no generic interface. They're all different APIs. And as we saw with FTP, there is a gap between support here. Some support strings, others support streams, or the other way around. And every other file system implementation will either have both or one of the two. So that's a hassle. I don't very much like that. On top of that, it gets even more depressing. None of the results are the same. Every call that gets returned has a different response. If we get a response back from AWS, it will be some sort of AWS result object. So every time we check for a successful write or a successful upload, we have to take into account what kind of storage system was backing this. That's not very nice. Imagine if you have different kind of storage systems, and you'd have to check whether it's an AWS response or it is a false, which means X in one system and Y in another. You don't want to go there. So based on that, you can say choosing a file system can create technical debt. The code that is uploading a file needs to know the implementation details of that file system vendor. So this in turn can create vendor lock-in. Say your application is very file heavy, and every bit of your application is using files, but it's using the storage directly. If you might want to change from using Rackspace cloud files to, say, AWS S3, and you'll have to change 50 or so classes in order to do that, that's a lot of hassle that you shouldn't have to go through. And in some cases, if it's so large and so integrated into your system, this can actually be the make it or break it thing that management might say, so, okay, it's you as a developer like this other tool better, but it's going to cost us so much to convert. I'm just going to say you can't do that because it's going to cost me a lot of money. So it creates vendor lock-in, and it requires you to invest. The first time I saw the AWS, it's getting more crowded here, SDK, it's quite a big piece of software. You really have to dig into it in order to know what's going on, know why you're using it, or how you have to use it. So it will require you to invest your time up front. So now we know what file systems are. We know how to use them. We know why and how we're going to move to remote file systems. Now we're going to use file system abstraction. So obviously, my solution to remove some of these pain points is to introduce a file system abstraction layer. But what is a file system abstraction? So file system abstraction is basically logic and structure that facilitates a generalized API to work with different file systems. But if you turn that around a little bit or rephrase it somewhat, turn it into questions like, what does a file system abstraction do? And in short, it bridges the gap between different file system implementation or packages and normalizes the response. So back to back, it will deal with everything in between. Of course, it would be kind of dumb if I was up here saying, well, file systems are not cool and they are a pain in the ass to work with, and then don't supply solution. About 2 years ago, a little under 2 years ago, I had a client and I needed to work with an FTP server, but I was at their office working on that, and that was okay. And then I moved to my own office and I tried to do some spiking on the FTP server to get some kind of responses, and stuff wouldn't work anymore. What turned out to be the problem is that the FTP server had a whitelist. And basically, that whitelist prevented me as a developer from being anywhere that I wanted to be. And me as a freelance developer, I don't like to be tied up at an office of a client. I want to be able to work from home or whatever. Remote working is the latest hype, so yay. But I couldn't do that. So I started up typing some basic instructions to get the same kind of interface for an FTP server that I had for my local stuff, which kind of worked. And that allowed me to not work at that office, but work from home. So for me, it was really liberating. And that was the initial version of Flysystem. So it's basically many file systems, one API. So if you look at what Flysystem is basically a file system abstraction layer. So you could say it's like similar like a database abstraction layer, but then for files. And I think it's pretty cool. So this is the first look at Flysystem. So on top you have everything that you need in order to set up Flysystem. So you import the local adapter, you instantiate it with a path to a root, and then that's the adapter, and then you plug it into the file system object, which is your point of entry of working with a file system. The name kind of suggests everything, so should be fairly easy to understand. And then we can look at some basic file system interactions, operations. So we can write, we can read, we can update a file, we can list the contents of a directory, we can delete a file, and we can get a MIME type. The functions that you can call is actually a little bit more than this, but as you can see here, all the methods are pretty much things that you can guess, and they say what it does. So writing is writing, of course, so it's not like upload object or whatever. It's more close to the actual file system thing. But, okay, this is all fine and all, but this is just local. Let's do something entirely different. Let's do something on S3. Okay, so we're done. What's happened? Well, basically, all that's happened is that the adapter is now different. We've got the AWS S3 adapter, which requires the S3 client to be injected in, and you need to specify a bucket name. But that's all configuration, so we do that once and we're over. We're done with that. So, but all the operations, they remain the same. The same could be done for FTP. So we have some kind of FTP settings. We've got our host and our login or our username password stuff. And still, once again, the file system operations, they remain entirely the same. I showed streams before, and streams in Flysystem are fairly easy as well. You just say, I want to read a stream, so read stream, and then we want to write using a stream. Fairly easy interactions, very easy operations. But if you look more closely to the example here, we're actually reading the stream from Dropbox and then writing to an S3 bucket. Just imagine how much code you would need in order for this to work if you would have to use the SDKs as is. I'm pretty sure it's not going to be 2 lines unless you write minified PHP code, which is kind of odd anyway. Already a lot of benefit. So what you could say is, it's basically one API to rule them all. So how does Flysystem do this? As shown in the examples, it uses the adapter pattern to enable the plugin of new adapters or different adapters. It normalizes all the responses, so you just get back, if you get metadata, you get back an Unix timestamp for the timestamp. Some will give back strings, but it's all normalized. And the same for the contents of a file. Some give you back some kind of object that you need to work with. This will just, if you ask for a string, you get back a string. If you want to stream, you will get a stream. Even if the implementation of that particular file system SDK won't support that. It will actually use polyfills in order to emulate that behavior. So you're good to go no matter what. It will also eliminate common gotchas in SDKs. For example, I told you about the S3 concurrent upload optimization. Using Flysystem, you won't have to do that anymore because that's handled within Flysystem internally. So whenever there's a file that's of a certain size, it will convert to multi-concurrency uploads for you, and you don't have to think about that anymore. But there's one other thing. It will make all paths relative, and there's a very good reason for this. If you make all paths in your application relative, your application code does not have to know about where it's stored, like on the actual disk. So the actual location of the disk becomes an implementation detail, something your code doesn't have to care about anymore, which in result makes everything super portable. So the root is an implementation detail. You can move your files at will, reorganize everything, and your application code does not need to change. To illustrate this, this is a full path of a certain text file in this case, app configuration domain concern. So the last part, this is what the domain concerns itself with, and the rest of the path is everything that your application does not need to care about. So if we would move this entire directory somewhere else, we put it in a new path, but our domain concern can still remain the same. So that's nice, and it's obviously a benefit, but there are more things that are beneficial in this way of working with it. Testing file system interactions becomes easier, becomes more reliable, and might even become fun again. Who in here tests their file system interactions if they use normal PHP stuff? I see 3 hands. Okay, I think that says enough, right? Common reasons not to test this is because testing file system interaction, especially in PHP, is hard. You have to either set up the file system for a certain situation, or use stream wrappers like a virtual file system. It's pretty hard to do this. I had to deal with all of those things in Flysystem, just so everybody using Flysystem does not have to do that anymore. But let's look at something that consumes Flysystem. So I've created a nice class, which is an author biography file system interaction service manager, because naming things is fun. And it relies on the Flysystem file system interface, which the file system implements. We take that as a constructor argument, and when we need to get the actual file contents for something that's related to the author biography file system interaction service manager, then we can call the file system read function in order to get the contents of the bio. So we can get the bio location, pass that in there. So if we want to test this, we can basically do this. This is a PHP unit test, just the single test, and we're using Mockery to mock the file system. Anybody not know Mockery? Do you know mocking as a concept? Okay, mocking, as the name kind of suggests, but also not. Basically, you create sort of a lie, and you say, give me an object that implements this, and you can set expectations on it, and when you use it, it actually sort of like plays back what you instruct it to do. So in this case, we create a mock for the file system interface, and we say it should receive a read call with jamesdoe.bio.txt, and when it does receive that, I want it to return the expected content. So the expected content here is some bio. And then we can go about, that's the setup, and then we can go about actually testing it. So we create the new author, well, the name was too long for here, so I shortened it. And we can do our assertions here. As an added bonus is, this will actually speed up your test suite a lot. If you have a very large application, you want to be able to keep running your test suite as much as possible. And when you use the file system is super slow. So I've seen test suites that have just 800 tests. And they would run for an hour because they use the actual file system every time. If you would then use something like Flysystem, everything can be run, but then it's only in memory. So this will drastically drop the time of your test suite. So that's a nice benefit, but there are actually more. So it improves the stability of dependent code. A class should preferably have only one reason to change. Changing file systems is not one of them. The code you have should not care what the actual path is where your files are stored. And Flysystem allows your code, if it depends on this, to be unaware of this, which is super beneficial. It also opens up new possibilities. For instance, if you have an application that requires large files to be uploaded, you can create a service that will handle large file uploads yourself, but you could also say, well, I know Dropbox is very good at uploading large files. Why don't I let the user upload it from Dropbox, and then behind the scenes, I fetch that file from Dropbox. So the user can go about still using your application. In the background, the user is uploading to Dropbox, and as soon as that's done, in your application, just say, well, I want that file from Dropbox. And it's going to be a hell of a lot faster. Not only can you do that in a background process, but server-to-server communication is always going to be so much faster than client-to-server transfers. So it's going to speed up the application a lot. Not necessarily like on application level, but for the user's perspective, it's going to be a lot better. I only showed a couple here, but there are actually quite a lot of integrations that work with Flysystem. So we've got local FTP, FTPD, SFTP, virtual file system for testing purposes, and pretty much all the major vendors of file system types in the wild. People have been picking up on this package. So there's a Symfony bundle, there's a Laravel 4 integration, Laravel 5 people in the house. Well, you're already using Flysystem then because it ships by default. Lumen, oh, that's wrong. It doesn't ship by default. It did, but then now they removed it. And there's things like Backup Manager, and that's actually a very nice use case. Backup Manager handles database backup, so if you have a MySQL database and you want to back that up, their domain and their expertise is making sure the interaction with a database is working properly. But they want to offload it to a storage engine, but should they be implementing every kind of storage adapter for that package? Well, they chose not to and depend on Flysystem instead. And out of the box, they all of a sudden support S3, local, FTP, basically everything. So they don't have to care about that anymore. As I said, this project is now 2 years old, mainly because the inclusion of the package in Laravel, the stats have been going off the charts lately. So it's actually been downloaded like 340K downloads per 30 days on average. Last month, I just hit 2 million installs on packages, which was, yeah, I thought it was a nice achievement, and several thousand stars on GitHub. People do weird stuff with anything they find in open source. That's also the case with Flysystem. People use it for Flickr uploads, which is okay, files. People use it for YouTube uploads, okay, movies, so files. But there's actually one guy who thought it was such a pain to talk with Redis over an API that he thought, well, what if I just write a text file and that's uploaded through Flysystem to Reddit? I don't know why, but you could if you want to. All of this is part of the PHP League, and normally I would tell you all about it, but we've got Phil Sturgeon in the room, and he's going to have a talk about that later. So I'll leave that part to him. Thanks for your time. This is all I got.